Okay, so this is the answers to the try it question at the top of page 2. And you can see, once again, I've labeled all of my categories here with their abbreviations. And I found the missing pieces using the subtraction technique that I used on page 1. So all of my answers here are in fraction form. I didn't do any decimals or percentages because I want you to be able to see exactly where I pulled these numbers out of the table. So take a look carefully. Remember that the numerator is always the overlapping region, and the denominator is always the total of whatever was at the end of the expression. So in this case, Spain, in this case, females, and in both B and D, Germany. Okay. All right, we're going to take a look at example 2 and see how this works with a Venn diagram. Now the Venn diagram here has already been completed for us, so we can go ahead and jump right into our work. We are told, if you read the information, that 80 students were asked if they take math and history classes. So these 4 values are going to add up to 80. Remember, we talked about Venn diagrams before, that this overlapping region is the intersection, and the sum of the 2 circles is the union. That's the his, hers, and ours together. Okay. The 17 would be the complement, whatever's left out of those 2 circles. So in example A, it asks us to determine the probability of a student who is in math given that they're taking history. So since this is my condition, we're going to look only at this history circle. So in the history circle, I want every student who's enrolled. So this would be the 14 and also the 26. I want that whole total. Now you don't have to write that as an addition problem. You could do the math in your head, but I just want to make sure we're clear where it's coming from. The numerator is going to be the shared piece. So this little section here represents students who are taking both math and history, so we would have just the 14. Okay, now it's really important that we follow the order of operations, and the order of operations tells me that I should add here before I do any division because there's this implied parentheses here. So this would be 14 over 40, and since I can, I'll go ahead and reduce that down, dividing both top and bottom by 2, and that gives me 7 over 20. 7/20 is 35 hundredths, or 35%. Okay. These other 2 examples are not conditional questions, but they're good reminders. Since there is no condition, I'm going to be working with the entire Venn diagram, which means that my denominator, no matter what, will be 80. Now, I also see that we have an or here. This symbol, this U, stands for a union, and so we're going to do the rule that we learned before, which will be the probability of math plus the probability of history and minus the probability of math and history. So, for the probability of math, we would take the sum of the circle. So, it'd be the 23 plus the 14 for a total of 37 students. For history, I would take the sum of that circle. So that'd be the 14 plus the 26, and that would be 40. Again, out of 80 because there's no condition. And then in my last section here, I would subtract the overlap. So as we did this, we counted the 14 here as part of the 37, and we also counted the 14 here as part of the 40, and we cannot count these people twice. So we're going to subtract that 14 back out. Okay. Then when we do the math, 37 plus 40 is 77, and 77 minus 14, oops, dropping my pen here. 77 minus 14 is going to be 63. Okay. And then that would be our final answer. Finally, our last question here is a probability of neither. We're looking for students who are not enrolled in math or in history. This also has no condition, and therefore we are dealing with the entire group of surveyed students. And so our denominator will be 80. In this case, we're looking for students that are not in either circle, and that's going to be this 17 right here. And so the probability of me selecting a student who is not in a math class or a history class is just 17 out of 80.